We're going to end this lesson with two application problems, and these come directly from my math lab, so you're going to have examples like this in your homework. Example 1 says a satellite dish is shaped like a parabola. If the signals that emulate from the satellite strike the surface of the dish and are reflected to a single point, where should the receiver be located? So what's cool about satellite dishes, they are parabolas, and no matter where it hits on this surface in that satellite, it's automatically going to bounce off and come right here to that center, which is essentially where the focus is. So if the dish is 6 feet across its opening, which we can see here, and 2 feet deep at the center, so essentially from the vertex up to the end of this satellite dish is 2 feet, not to the receiver, but all the way through. What position should the receiver be placed? That is, where is the focus? So this right here is my focus. So the easiest thing to do is kind of draw a rough sketch of this. So we can make this parabola open any way we want, up, down, left, or right. I'm going to make it open up. So with my satellite dish, I don't know how I want to do this, is something like this right here. Okay, and my focus is somewhere in here. So we need to know where this focus is, and so we need to figure out if my vertex is right here, we need to figure out A, right? We need to figure out the distance from the vertex to the focus. If I'm using this version of my parabola opening up, and again, we can do it any way we want, but if I go opening up, here's my formulas. Opening up, I need this version of my formula right here. Now, if my vertex is at 0, 0, x minus 0 is just x squared equals 4a x minus k, since again 0 is just y. So this version is this when I put in zeros for my hk. Now, not a lot to go on because I don't know what that a is, and that's what we've been relying on for this. But what I do know is a point on this parabola. What would this ordered pair be of this point here? So pause the video if you want a little bit more time to think about that. A lot of times when I'm teaching this in class, I get 6, 2. But this is going to be 3, 2, because if the whole thing is 6, from the center to the edge will only be 3. Now I don't need the point over here, but this point here would be -3, 2. So now that total length right there is 6. So if I know one point on this parabola, I can plug that in and solve for what I need. So ordered pairs are always on the form of x comma y. So here is my x and here is my y. And you can also use -3, 2 and you get the same answer, but I'm going to use all positives. So when I plug this in, we have 3 squared equals 4a times 2. 3 squared is 9. And so you can see if you do -3 in parentheses squared, you also get 9. 4a times 2 is 8a. And if I divide my 8 over, I'm going to get a equals 9 over 8, which is the same thing as 1 and 1/8. So now I have that distance of A from my vertex to my focus. So word problems need word answers. We have found that the receiver should be placed 1 and 1/8, and we are unit of feet from the base of the dish. I guess you couldn't see anything I was writing. Sorry about that. Okay, the receiver should be placed 1 1/8 feet from the base of the dish. Guys. Okay, I was gonna stop recording, but I forgot we have another video here. So here we go. Where is my other paper though? Here it is. Okay. Just kind of losing my mind here, not a big deal. Example 9. A bridge is built in the shape of a parabolic arch. The arch has a span of 120 feet, which we can see in this diagram, and a maximum height of 25 feet above the water, which is also represented. Choose a suitable rectangular coordinate system and find the height of the arch at distances of 10, 30, and 50 feet from the center. Okay, so let's draw another sketch. And my bridge. Start here. And go to here. And it's going to be something like that. There's my bridge. So we do know a couple ordered pairs on this. First, we know that vertex. What would this ordered pair be right here if we know that the maximum height is 25? That's going to be 0, 25. And then we know both of these endpoints here. We only really need one. What would this one right here be? A is not 120, 0. Going from the center over, half of that would be 60. Now again, we don't need it, but this over here would be negative 60, 0. And so now that's got a whole length of 120. So if I am using this parabola here, when I look at my formulas, which shape are we using? We're using this one here that's going down. So I need this formula. I'm going to rewrite it down here. And now, here we go. I need to make my equation for this parabola here. So I do know one thing. I do know the vertex. So here is my H and my K. So I'll go ahead and substitute those in. We have X minus 0 squared equals negative 4A, Y minus K, which is 25. So I can clean that up a little bit. We have X squared equals negative 4A, Y minus 25. So now all I need is my A. I have no idea, ouch, I have no idea where this focus is. Honestly, this focus could be above the x-axis, it could be at the origin, or it could be below the x-axis. I have no idea where it is. So how did we find A in the last problem? In the last problem, when all I needed was A, I plugged in 3 and 2 into X and Y. Where did this 3 and 2 come from? That was one of the ordered pairs that I knew. Here I have 2 ordered pairs that I know. Pick one of them, doesn't matter which. If I go all positives, here's my X and here's my Y. So from here, I have X squared, so 60 squared, equals negative 4a, y, which is 0, minus 25. So if we solve for a, square this and we get 3,600, which if we use this ordered pair instead, when we square negative 60, we'd still get positive 3,600. So you get the same answer. We have negative 4a times negative 25. Now we can do this two different ways. Honestly, kind of the easiest way is to multiply these and divide that over. However, this formula is almost complete. All I am needing to do is substitute something in, technically for a, and then it would replace this entire 4a portion. So instead of solving for a and substituting it in, I'm just going to solve this for negative 4a. So if this is negative 4a times negative 25, I'm just going to divide by negative 25. Those cancel. And I get negative 144 equals negative 4a. So now I have solved for 4a. I'm substituting what 4a equals, which is negative 144, back into here. So now this becomes x squared equals negative 144 y minus 25. Rather than solving for a, multiplying it again by negative 4, just solve this thing for negative 4a and substitute that whole thing back in here. All right, now we're almost done, and we could be done. But if we come back up here, it wants us to find the height of the arch at distances of 10, 30, and 50 feet. So we need to ask ourselves, what is 10, 30, and 50 representing? Is this representing X or Y? Find the height of the arch at distances of 10, 30, and 50 feet from the center. This right here is our X. Find the height of the arch. So I'm finding Y at distances of 10, 30, or 50 feet from the center. So I want to know when I go 10 feet out, what is my Y value? When I go halfway, when I go 30 feet out, what's my Y value? And when I go 50 feet out, what is its Y value? So because I am given X and I need to solve for Y, make it easy on yourself and rewrite this equation where it equals Y. So if I continue on working this problem, to get Y by itself, we could distribute in that negative 144. But the opposite of distributive property is to divide. So I'm going to divide this side by negative 144 and divide this side by negative 144. So those cancel. I have x squared over negative 144 equals y minus 25. And now to get y by itself, add that over. So we have y equals x squared over negative 144 plus 25. So now I can plug in x equals 10, x equals 30, and x equals 50. So let's do that real quick. And it'll help you. Here we go. All right. So I have 10 squared divided by negative 144 plus 25. Change my 10 to a 30. And change my 30 to a 50. Let's kind of look at our diagram here. That kind of makes sense. At 10 feet, am I 24.3? Very possibly. That is super, super close to that top. At 30, we're at 18.75, which we're still pretty far up there. And then at 50, we're at 7.63. So it makes sense that those numbers are decreasing along that Y as we are going further and further out.